A pleasant morning to everyone. Welcome to our senior high school lessons in statistics and probability. So for today's lesson, we're going to have the central limit theorem and the sampling distribution of the sample mean. Are you ready? So let's start. Let's have the objectives of this lesson. You are expected to illustrate the central limit theorem and define the sampling distribution of the mean using the central limit theorem. How was your day today? I hope you're doing all fine. So before we start with our lesson, let us have this definition. What is the central limit theorem? It states that the sampling distribution of the mean approximates a normal distribution with the mean of mu and the standard deviation sigma over square root of n if the sample size n of the random samples is large enough. So to know more about this, let us have an illustrative example. Given a die, it has 6 faces in which each face has either dots of x is equal to 1, 2, 3, 4, 5, and 6. Given it as a population, consider the samples of size n is equal to 1 and n is equal to 2. Given this illustrative example, let us illustrate the central limit theorem using the sampling distribution of the sample mean. So recalling our lesson and the sampling distribution of the sample mean, we are going to consider the number of sample size. So for this one, we have if n is equal to 1, what will be our sampling distribution of the sample mean? From the population of 1, 2, 3, 4, 5, and 6. And then we can get the mean, variance, and its standard deviation. So the value of the mean will be 3.5, the variance will be 2.92, and the standard deviation will be 1.71. Let us have this solution for the mean, variance, and the standard deviation. So to get the mean, we have the summation of x over n, which is 1 plus 2 plus 3 plus 4 plus 5 plus 6 all over 6. So that will become 3.5. Meanwhile, the formula for getting the variance is the sigma squared is equal to the summation of quantity x minus mu squared all over n, which will give you 17.5 over 6, which is equal to 2.92. And in order to get our standard deviation, that is sigma is equal to square root of the sigma squared, or the variance, which will be equal to 1.71. And considering the sample of size n is equal to 1, we can get this table containing the sample mean, and its probability. So as we can see, the population mean and the sampling distribution of the mean are both equal, which is 3.5. And it also has a variance and standard deviation approximately of 2.92 and 1.71 respectively. So since all the samples have the same probability, which is 1 over 6, so the trend of the histogram is like a flat line horizontally. And now, considering the same illustrative example on a die, and you're going to have samples of size n is equal to 2. So if n is equal to 2, we have another set of mean, variance, and standard deviation, which is equal to population mean of 3.5. So also the sampling distribution mean, which is 3.5. A variance of 1.46 and a standard deviation of 1.21. And the same with the previous example, this is the solution for the mean, variance, and the standard deviation. So after getting the mean, variance, and the standard deviation, let us have the sampling distribution of the mean. So we have in this table, it shows a total of 36 samples and the probability of each sample. So based from the sampling distribution of the mean table of n is equal to 2, you can see that the population mean and the sample mean is just the same, which is 3.5, and it shows a variance of 1.46 and a standard deviation of 1.21 approximately. So most of the data are concentrated at the middle values of the sample mean. So as you can observe in the graph, the data gathered resembles that of normal curve, which supports the data or idea of a central limit theorem, which strongly suggests normal. Now it's your turn. Illustrate the central limit theorem and sampling distribution of the sample mean given the die, which has 6 faces, which is x is equal to 1, 2, 3, 4, 5, and 6, considering samples of n is equal to 3. You can do it. It's time to summarize our lesson for today. Recap number 1, what is central limit theorem? And number 2, how to illustrate the central limit theorem and sampling distribution of the sample mean. You can also accomplish your learning activity sheet number 8 on page 5. So again, thank you for joining me today's lesson. See you again next time. Stay connected and stay safe. Bye. This is Mom Grace.